So I want to end this section. So I want to end this lecture by a small derivation of the relativistic formula where the velocity, the modulus of the velocity of a particle is given by the modulus of the three momentum divided by its energy. So this is something that is quite often used in particle physics, and I just want to quickly derive it in case you haven't seen this before. So let's start with the definition of a four momentum. In relativity, the definition of a four momentum is mass times the four velocity. The four velocity is the derivative of the coordinate of the point, but with respect to the proper time. So tau here is the proper time. So this is, we can write this in terms of dx mu dt, where t is the time coordinate. So we have to, then using chain rule, we have to write it like this. Now, if I look at the three-dimensional component of this vector, so then the three-dimensional momentum m, p will be equal to m times, and this then will be just the three-dimensional velocity. And here this will be dt by d tau. But remember that the relationship between the proper time, d tau, and the time in the inertial coordinate, inertial reference frame, is which is moving, in which the particle is moving with the velocity, say v, is given by this formula. And therefore, we can replace dt by d tau by 1 by square root of 1 minus v squared. And then what we can do is we can invert this. We can take the modulus of this. So if I take the modulus of this, I get p mod, and here I get m times v, and here it's 1 minus v squared. So I'm taking the modulus of this equation. And then what we can do is that we can square this equation. If we square this equation, we get three-dimensional momentum squared, m squared v squared divided by 1 minus v squared. And then we can invert this relationship. If we invert this relationship, we get 1 over p mod squared. And then what I can do is that I can bring the m squared to the side, and then I have 1 minus v squared divided by v squared. Then what I can do is that I can add 1 to both sides. If I add 1 to both sides on the left-hand side, I get m squared plus three-dimensional momentum p mod squared divided by p squared. And on the right-hand side, I get 1 minus v squared divided by 1 minus v squared plus v squared divided by v squared. So here we see that we have v squared cancel out. And here we see that the numerator on the left-hand side is the energy of the particle squared divided by the p mod squared. And that is going to be equal to 1 over v squared. And therefore, we have derived that v is going to be equal to the modulus of the three-dimensional momentum divided by the energy. And this is a formula that is quite often used in deriving formulae for cross sections.